Are you saying anything?
Hi, Jesse.
Oh, wait, Jesse. Oh. Oh.
Oh,
Oh, they're twins. Oh. Oh, yeah.
You're forgetting people? They're in our class.
Jesse and Gwen.
Who is this?
I forgot to have my other class, my first class to vote on your child today. I forgot to have the second class vote. Crap. Okay, we are learning two minor little topics today.
We're not.
Yeah, we are.
Alright.
They're not anything super duper major. One of those, we define the area of all these curvy figures. But what if I just say how long is that curve I have drawn there?
Approximately 29
inches. Approximately 29 inches. Okay. Okay. How do you come up with the length of something curvy?
You don't.
Well, if you could straighten it out, you could attempt to get a string and match it exactly.
You get a ruler.
A ruler?
It's totally
How
gonna work.
are you going to use a ruler to measure a curve? Yeah, baby ruler. Like,
Or you do like a tangent of it. Not a tangent, but
I know, you just take the
it's
ruler
not
and you
that
just
far off.
follow the string with the ruler.
Okay, well, I'm actually going to pick out a point A and a point B here. So if I go up with...
Hey, we don't use that kind of language in the classroom.
So I am looking for how long is the curve between point A and point B. That's what I'm after. Okay. What they do is kind of like how did we find the area? What did they do first when we wanted to find the area? They divided it into what? They divided it into little rectangles. Okay, in our case we're not doing area. I just want to know how long the curve is. So the concept is, let's just divide it up into little segments that are lines.
I was so right. No, you weren't. Yeah, I was.
So there's just like, they're saying, okay, let's divide it right there and find that little segment, and then we'll put another little segment in. Dylan, sit down. Then we'll put another one in, and another one in, and we'll just keep adding up all those little segments we divided up into. Do we now know how to figure out how long a line is? The distance formula. So if we can come up with coordinates, we can do the distance formula. So, yes, we are developing theory here again. We need to come up with some coordinates for our points that we're using. And I could actually pick any of these. I am going to pick this point right here and call it X. And I'm going to pick the point next to it and call it X sub 1. I need to come up with a formula to find the distance of just that one little segment. Dylan, sit down. No, he wasn't. He was poking Ellie.
I was making her smell the hand sanitizer. Yeah. I got her real good.
Actually, it's correct. I want to find the distance between those 2 points. I'm going to do distance formula. Okay, so tell me the coordinates of this point at X. I'm X over, and how do we always figure out how much far up we are? F of X. How high the function is, that's your Y coordinate. So we would say that's F and F of X. And then our second point is going to be, since it's at X sub 1, its coordinates are going to be X sub 1 over, and how much up? F of X sub 1. So I have those two coordinates there. Do we know how to do distance formula between 2 points? Distance formula. Yes.
Fy cubed 3 squared.
Thank you, squared. Okay. So we are going to fill that in, except we are going to use our two coordinates we just put in here. So we are going to be doing square root of, our right-hand point is F of X sub 1. Or not F of X, sorry, it's X sub 1, sorry. Minus our X. Then our Y coordinates are F of X sub 1 minus F of X. And you're going, okay, great, that's lovely, lots of symbols.
Yes.
Well, somebody got to looking and going, F f of something minus f of something, and x minus x. You ever seen anything that's sort of like that?
Nope. I don't think so. I agree with you.
I'm guessing there is.
I don't think so.
Well,
I was on the radio class.
person who noticed said, hey, actually don't know who developed this formula. Might be me. This, they noticed, what, what? Definition of a derivative. Yes, you remember our good friend. The limit as x approaches a of f of x minus f of a all over.
We got this. Trust us.
Maybe a line.
Don't doubt us, Byron.
Okay. So I would like to make this look sort of like that. So I need these x's here in the first part of this square root to be under the f of x. So they said we're going to divide everything. If I want to get it so, let me change color here so you see this. I want to get it so that I have x1 minus x over here. So well, actually they said, no, we're just going to divide it all by the same thing. As long as I divide it all by the same quantity, it'll work. Well, what happens, yeah, the first part of that square root then becomes a 1. And I just have 1 plus. And since both the top and bottom here are squared, can't I just put that as f of x sub 1 minus f of x all over x sub 1 minus x and put it in a great big giant square? Okay. Now, is that the definition of the derivative?
Yes.
Nope, but it's missing part of it.
The D and the limit.
The limit. Okay, right now, all this is doing is this is finding us the length of one of these little segments. I want to find the length of this whole curve. So what do I need to do with all these little segments? I need to sum them all up. So some sigma action here. Sum up from A to B. But in order to truly be measuring that curve accurately, I need those little pieces to get really, 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 really small. So I need a limit, and yes, I need to let what approach 0? Or am I approaching 0? I actually need what, since I'm working with point x and x sub 1, what do I want those 2 points? Yeah, do you want x sub 1 to get, you want those two to get really close together? So yes, Amanda, thank you. You even got it in the right order. You need x sub 1 to approach x. Okay, so consequently then, with the magic of calculus and the 15 minutes on the rest of this proof I'm not going to spend since we've seen it before, somebody went, but hey, whoa, wait a minute. The limit of a sum can really be changed into integration from A to B of 1 plus, and then this thing here, that whole fraction thing, is really what? I got the limit now of f of x1, that's the derivative. So in reality, all you have to do is the derivative squared.
Why can't you done it to start with?
So that is actually the formula you need to find the length of a curve. Because I wanted this point x1 to get really, really close to x. Because I want these distances on this curve to get so small that there's like measuring every little tiny dot length, and then you can actually say you've got the exact length of the curve. Okay, so actually that's the hard part, deriving the formula. Working the problems is pretty simple. So that's the formula you need. They're going to give you something like this. They're going to tell you your function is 2/3 times x minus 1 to the 3/2 power. And they're going to tell you you're trying to find the length of this curve from 1 to 4. They have to give you a starting and ending point. Okay. You need to find the length of the curve. So according to our handy-dandy formula we just created, what should I do?
Not
should ask you this. Do you guys remember what letter of the alphabet they used to represent arc length? I did it last, yeah. So technically this is
Oh,
S.
yes, we can never
Is
forget.
she awesome?
Math doesn't matter.
Oh.
We will never forget this, because Ashley doesn't think that matters.
Okay, before you fill in this formula, what one thing do you need to do? What do you have to know before you can fill in that formula? The derivative. So you have to remember, how do I take a derivative? Yeah. It'd be called a little chain rule action here. So if I take 3/2 out front times 2/3, that's 1. If I really get 1,
whether that was planned or not.
not a bit. X minus 1 to the what power? 1/2, because you have to subtract 1, you're doing a derivative, so you'll have it to the 1/2 power. Technically times the derivative of the inside, which in this case is a convenient 1. So in reality, what you got there, and do you want to leave it as a 1/2 power, we can put it in the square root, whichever floats your boat. Square root, so what you really got out of that is square root of x minus 1. Then go fill it in the formula. Once you've got that figured. Okay, so Dylan says, to get the arc length here, I am integrating from 1 to 4. It says do the square root of 1 plus our derivative, which is square root of x minus 1. But then it says the formula calls for us to square it.
That's really easy.
Yeah, why did you say that's really easy?
Because it's just going to be 1 plus x minus 1, so it's going to square root of x.
Yeah, it's just going to be 1 plus, the square root's going to go away, so the 1s are going to cancel, and yeah, it's really just the integration of from 1 to 4 of square root of x. Which we could work by hand, but given that I'm running out of space here, it comes out to be 14/3.
Still got a couple minutes left.
So what kind of unit do you label it with? Yeah, it's a length. It's just unit. That particular curve would be 14/3, or about 4 2/3 units long.
Big deal.
Wow, was that amazing?
No.
So, why don't you have to graph them? You don't need a graph. You're not looking for a top minus bottom, a right minus left. You don't have to have a graph. You just
So
go
like,
in. After all the fun we've
hate is a
done,
strong word. Dislike.
okay. Actually, now's a good time to pause before I go to service.